Megan Wong. I'm from the Australian Research Data Commons, and welcome to our session on federated and interoperable vocabulary services. I live and work on Jara country in central Victoria, Australia, and I'd like to begin this session by acknowledging the traditional owners, the Turrbal and Yagara peoples on the land which we're meeting today, and pay my respects to their elders, past, present and emerging. So today we've got some great presentations on core issues of the federation and interoperability of vocabulary services. And we've got some great demonstrations, practical demonstrations of solutions and thought-provoking discussions on future directions. So we'll kick off with the talks to set the scene, and then we'll follow up with a discussion on ways and approaches for moving forward. So what I'll ask is that you pop your questions in the chat and hold your questions for that discussion session at the end of the speakers. Hello, Brandon Whitehead from Manaku Whenua online. He'll be watching the chat. Now we do have, just waiting for the slides. You have to use the remote.
What do you point the remote at? I'm sharing the screen, Megan, right now. So which one do you want to be on?
Okay, we're just waiting for them to progress the slides here. Oh, okay. Oh, here you go. That's great, Clement. Good to see you. So we've got session notes here. Please scan that, jump in, add your name and your affiliation and any notes. And interestingly, the co-authors here have come up with a bit of a statement to collaborate that we drafted up. So we'll pop that in the Google Doc as well, so we can have a chat about that in the discussion session. So I'll pass it on to Clement. He's just going to give a couple of words to kick off, and then he's actually the first presenter this afternoon. Clement Jonquet is from INRAE MISTEA and the University of Montpellier. He'll be presenting approaches to vocabulary services or semantic artefact catalogue interoperability, studied in the Fair Impact project. So thank you very much, Clement. Welcome.
Well, thank you, Megan, and thanks everyone for being here. I hope everything is fine with the audio and the video. So I think I'm sharing my screen right now. So I'm going to move on from
yes,
them.
we can see the QR code.
Okay, and as you said, I'll do the quick intro of the session today, and I need to grab my watch to be sure we stay on time. And I do also my little talk introducing also a little bit some of the work we've done. So 8:04, we're good. It's 8 a.m. here in Europe for some of us, and probably even sooner for some others. Just want to come back one slide and say that I also acknowledge on my side, although I wish I would be there with you acknowledging in person, but you know, that's sometimes hard to travel all over the country to acknowledge also the fact that Australia has been committed into this International Data Week. So thanks for the organizers. Thanks for also the local support, your help, Megan, and all of that. We are today here to discuss some element in the current landscape of vocabulary systems, vocabulary services, and in that system, we'll be interested in acknowledging also the differences and the difference in technology and the difference in practices, and try to see how we can federate our work. So you see that different dimensions around the vocabulary ecosystems are here, and the goal of today is to present a little bit some of recent works and also discuss in the context of the panel some efforts that can be done to federate those systems, so we can envision a future altogether. So this is really the session goal today, effectively progressing vocabulary service federation. You'll see a little bit what we mean by that notion of federation during the talks, with some successful outcomes that will be really our first, the fact that we appreciate the elements there, and then everyone understand what we are talking about. We will see all those different tools and services and approach that we are working on can be maybe more working together and see what we can get out of those collaboration. Overall, I think the vision will be to facilitate the way people use and leverage semantic artifacts, vocabularies. I'll use that term. So yes, indeed, I used that term, and I wanted to just put a couple of definitions in the context of this talk, or at least the talks that we have been doing in the context of some of the EOS projects. We use the term semantic artifact as a broader term to include ontologies, terminologies, taxonomy, thesauri, vocabularies, metadata schemas, and standards. And we sometimes use also the expression semantic artifact catalogs. That is a term to encompass different expressions like ontology repositories, vocabulary services, registries, metadata schemas. And so the key idea is really to come up with an expression that is overarching different level of semantics, semantic artifacts. And so without like spending more time defining, oh, I think it's better an ontology than a vocabulary, or this one is more terminology or taxonomy. And in terms of producing and presenting the context, I just want to mention that in Europe, I mean, the Research Data Alliance is super strong in Europe also. And you may have heard about that program called the European Open Science Cloud that is supposed to build at the European level a huge cloud of services for folks around exchanging data science and the use of data in science. So not only and indeed, semantics plays an important role in this context, and there is an interoperability framework for the different components of that cloud to be more working together, interoperable. And you see that semantic artifact catalogs, mapping repositories have been identified as key elements of building such a framework, and that's more or less where we are. I mean, working on those aspects, but that set up the context of a multi-millions European program. In which people want to do open science with sharing data. And in the context of, you'll see a couple of these slides coming from Fair Impact, one of these projects founded under the roadmap of founding EOSC. We've done a review of different semantic artifact catalogs, technologies to build them, and we reviews 173, and now it's even more. We are probably around 183, 84, because I've added around 10, 12 since the deliverable was published last year. We review technologies, and we try to also see how it will help the semantic artifact to be fair when they will be deposited in those semantic artifact catalogs. So I really send you back to this report to see a little bit of the diversity of the word that we are talking on, and you get a vision or an idea why we need to federate our stuff. And beyond all of that, I like to carry along a little bit with this slide that says that the very motivation why we are building those services is to support our community in making their data fair. And to do that, we also apply the FAIR principle to ourselves, making vocabularies fair object. And the fact of having them deploy and accessible in ontology repositories or semantic artifact catalogs really make them fair. This is something I usually argue a little bit on. Okay, so that was to really bringing the picture, and you'll see that flows into the first presentation that I'm giving now on some work, and you'll see the multiple some work that we have done in Fair Impact, and you'll see me coming back again also to present one of these approach in more detail. But at least Fair Impact was one project that was interested in that notion of interoperability of those semantic artifacts because of the missions I have mentioned before, but also because of that diversity of technology and product that I've also mentioned before. So let me just briefly explain 3 approaches that we have studied or looked into in the context of Fair Impact. Or am I with the time? 8:10. So really Fair Impact was one of these projects in the EOSC ecosystem where we wanted to be sure we could provide some kind of a framework for semantic artifact with interest in the governance, the mapping, the sharing, the reuse, the fairness assessment, the interoperability in general of those semantic artifacts, and then their catalogs. So really, Fair Impact had a work package dedicated on that. And in 3 years, that's what we have achieved. Everything is one slide here. We have supported different existing catalogs. We've developed new catalogs in different communities. We work on a fair by design methodology that was focused for semantic artifact. We work on fair enabling tools. We've done that review that I explained about the current and retired catalogs. And we use data semantic artifact catalog within data repositories to show that it was useful. And we also work on a metadata standard for describing semantic artifact and an API for semantic artifact catalog, an API specification. And that's kind of the work I'm going to present a little bit today to explain a little bit the philosophy of the different approach we've studied. And we have done also some of the early work on the federation of the four catalogs, semantic artifact catalog, that I will present later in another presentation. So those three approaches are basically three approaches that we have studied are basically kind of summarized here. We basically understood, and you'll see a little bit about each of them today. We basically said, okay, if we want people to work together and have their semantic artifact catalogs, services providing semantic artifact, talk the same language, then we need to set up an API for that, a specification API that everyone can implement. That's the approach on the left, called MOD API, where every semantic artifact catalogs implement a share, eventually becoming standard API. But because we were also part of the project with like 3 or 4 catalogs already using a technology called OntoPortal that I had a chance to present a bit more in detail before, and that I think is actually currently presented in another room inside in the meeting. But because some of us were already using the same technology, then we also wanted to demonstrate that the federation of those tools were possible. And so we said, well, look, if those semantic artifact catalogs are already API interoperable because they use the same technology, maybe we can federate and at the UI level and demonstrate their value added of such a federation, having each portal consuming the content of one another. And in parallel of Fair Impact, another project in Germany called TS4NFDI that will be quickly presented by Ralph, studied the question of implementing a gateway to semantic artifact catalogs. So rather than asking them to do something, the idea of the gateway was we will do something in the gateway, and that's the gateway that will actually connect to the different technologies of semantic artifact catalog. And so those approaches have different advantage and drawback that are summarized here, and there are, of course, that we can always debate for sure, but that was the philosophy. Let me just tell you a couple of things related to MOD. So the approach on the left, and then eventually later we'll have detail by other speakers on the 2 other approaches. So MOD is really something that we can put at the center of such a workshop today on federating semantic artifacts and their catalogs. MOD has been there for like now around 10 years. Originally, it was a proposition to build really an ontology for ontology. You know, one of those semantic vocabularies where we'll be describing semantic artifact with a dedicated vocabulary for that. There have been some historical approach in the community for that, like OMV or ADMS or things like that. But MOD took them all and tried to harmonize them. And eventually in his version 2 and then 3 became an extension of DCAT. So some of you that are familiar to DCAT will recognize here the notion of dataset and dataset distribution. Then we have extended DCAT for MOD, trying to explain that we could have and we could build semantic artifact catalog with this model. And that the property that you will have for describing semantic artifact and those semantic artifact distribution will be formally described in MOD. And with a tool
that's 1 minute, Clement. Thanks.
Yeah, and with a tool, with a specification of a standard at end, then we would be able to implement a standard API for that. So tells everyone, implement that API, and you'll be MOD compliant, MOD API compliant. That's what we've done, and we have even set up an open call in the context of Fair Impact that some have adopted, and now we are multiple semantic artifact catalogs that are now interoperable because of that implementation, that MOD. This is exactly the results, and some of us will be presenting today, including, for example, Alexandra coming right after. So this is the last slide. I will say, well, I've tried to finish a little bit the presentation like that with like opportunities. What are those opportunities for emoji API? So the main element that I've presented it here really will support interoperability across data catalog, across semantic artifact catalogs by providing share access. It will help us to build such a federated ecosystem, and it will enable us to do that technical harmonization keeping into consideration the heterogeneous implementation that we have on our side. And it will clearly be something that we can push for integration in research infrastructures and things like that because of that diversity, that we could respect every project can have that. So that's the very first approach that we would like you to remember. You'll see several ones in the next 2 minutes to come, and we'll be able to discuss them in the context of the panel. Alexandra, I think it's for you. I'll pass the slide maybe if you guys want, or I can.
I'm happy, Clement. Yeah.
Oh, hello, Alexandra. How are you?
Hello. Good morning.
Just have a bit
afternoon.
Of a Clement, come on, I think.
Yeah.
Hi, Alexandra. Alexandra Kokkinaki from where are we? The British Oceanographic Data Centre, BODOC. So she will be presenting adapting mod API in the NERC vocabulary server, NVS. Thank you very much.
Thank you. Clement, can you click on the next slide, please? Yeah. So NVS, if you don't know what it is, the NERC vocabulary server is a semantic artifact repository for standardized hierarchical terminologies that are used for the management of data in the marine and related domains. We store and share vocabularies, terms, and the relationships between them, the mappings, in a human and machine readable format. Next, please. I think you have to click 3 or 4 times because I had some animation there. Brilliant, thank you. So NVS is built, exposes its data through a Spark endpoint, so it has RDF. And on top of that sits the technology of VocPres. Nick is here and he will talk a little bit about that. So we use VocPres to expose our vocabularies. We abide by the standards, so we use RDF. We express and describe the vocabularies with SKOS, the Simple Knowledge Organization System, and publish the vocabularies in different serializations like RDF XML, Turtle, JSON-LD, and many more. We also use content negotiation and content negotiation by profile. And you think that all this is enough to be able to be interoperable with each other and enable the federation of vocabularies. But let's go to the next one. So a recent challenge we faced was during the development of the semantic analyzer, which is a tool that people can upload terms or data sets related to the environmental domain and then analyze them. Can you click Clement a few times or one, and then analyze them against a knowledge base that we had to build to include several of the environmental domain vocabularies, because that wasn't easy to get from what is out there currently. So we did find difficulties bringing all these different vocabularies together into the semantic analyzer's knowledge base. And towards the end, I'll tell you what our wish is. So let's go to the next one. Can you click one back, Clement? At the same time, the semantic analyzer gives access to the Onto portal technology, so BioPortal and Earth Portal, and our wish is to, instead of us having to maintain a knowledge base with different vocabularies, to be able to plug and play different vocabularies that are collected for the different domains that we want to analyze our datasets against. Next one. So although we comply with all these standards, interoperability can be challenging. So we were invited by the Fair Impact project to implement the MOD API. So we didn't want to reinvent the wheel because we already exposed a lot of our vocabularies using a certain approach. So we tried to reuse what already existed. A challenge we faced is that not all of the MOD API endpoints were implementable for NVS. Some of the properties were not present in NVS, and our solution was to implement what makes sense, represent only what already exists. We found a lot of beneficial properties for the NVS, and some of them we filled them in, and some of them we said it's a nice to have, and we will plan to fill them in the future. Next one, please. So in terms of the technical implementation, again, we tried to use what already existed. So we added new routes to the FAST API because this is what VocPres uses. All of our endpoints are now listed in the Swagger documentation. Some of the challenges, again, we faced, so everything was quite straightforward to implement. And it was some good additions during the Fair Impact project is that we did do co-development with the rest of the developers, which was challenging, but extremely important to be able to be on the same page while developing. CFAX, from one of the people that participated in the Fair Impact project, developed a validator that we could validate our outputs, and it was great that the MOD API was first implemented by the Acro portal. That was the leader for us to follow. Next one, please. This is a list of the endpoints added on top of what already existed in the NBS. Next one, please. And this is how it looks. So currently, of course, there is just machine readability, so just JSON LD. So this is what you would be getting when you go to these endpoints. Next, please. And some thoughts. I think most of you have already realized that standards are open and can be implemented and interpreted slightly different by each one of us. So the fact that we were co-developing the MOD API was extremely beneficial to see that each one of us was thinking of a quite different thing. So just an encouragement to stay connected because linked people can lead to linked data. The MOD API made the first step. And for us, the wish is that for the semantic analyzer, the tool I showed you before, is to be able to reuse existing semantic artifact catalogs to perform semantic analysis of datasets, terms, and lists, rather than reinventing the wheel. Thank you.
Thank you very much, Alexandra.
Thank you.
Next, we have Ralph Schaefermeyer from InfAI, TS4N FDI. I hope I have that right. Terminology services for the German National Research Data Infrastructure. And he will be presenting on the implementation of API Gateway as a unique endpoint to Vocabulary Services Federation.
Thank you very much, Megan. Yes, I'm...
We're giving you a clap, Ralph. Sorry, I'm a bit slow on the clapping. How are you going?
All good, thanks.
Good, we can see your slide.
Perfect, can you hear me?
Yes, very good, you're right to go.
Thanks. So thanks for the gentle introduction. I'm actually replacing one of my colleagues, Naouel Karam, who unfortunately cannot be joining today. So I hope I get everything right. So together with Naouel, I'm working in the project Tiers for NFTI at the Institute for Applied Informatics in Leipzig, Germany. And what NFTI is, I will present on the next slide. If you can show the next slide, Clement, please. Thanks. So who are we? Tiers for NFDI stands for Terminology Services for the National Research Data Infrastructure, or the German translation thereof, so hence the F instead of an R. The NFDI initiative is quite huge German national initiative with the aim to make research data sustainable, transparent, and public. And is funded by the German state and federal government. Also, the overarching principle is the FAIR principle, so which Clement has already mentioned. And the whole initiative consists of 26 domain-specific consortia. So there's one consortium for each of the scientific disciplines, as you can see on the left-hand picture. In the outer white circle, these are all the domain-specific consortia. And then in the middle are the tasks that are kind of overarching the whole initiative. And in order to take care of these tasks, there's one overarching joint initiative, which is called Base for NFDI, which is, well, has the responsibility to integrate and establish basic services as common interoperable solutions. So one of the main tasks of Base for NFDI is taking care of metadata in order to make research data findable, accessible, and so on. You could move on to the next slide, please. Thanks. So the problem that so Tiers for NFDI is part of Base for NFDI, and the specific problem that we are supposed to solve is one of the problems that, well, Clement has already mentioned, which is integration and federation of which we call terminology services or semantic artifact catalogs. So we all know that there are already terminology services existing, and they have different APIs. They follow different standards, or kind of have established their own standards. Examples are OLS, then OntoPortal, which Clement has already kind of introduced, SKOS, and so on. So if one application is supposed to access several of these endpoints, it has to implement all the APIs. Next slide, please. So the approach that Tiers for NFDI with the API gateway takes is, instead of implementing or making the providers of catalogs of semantic artifacts or terminologies extend their services in order to implement a standardized API, we kind of create this gateway in the middle that is supposed to translate between the APIs and offer one common endpoint, one single API for all the different terminology services that are connected to it. So this allows for accessing, oh, sorry, not yet. Could go back. This allows for accessing all these different terminology services using one single API, and also to run federated queries. So if I connect several terminology services to the gateway, I can treat them as if they were one big terminology service and run one single query against all of them. Okay, next slide, please. If you want to have a look at it, there's a public prototype already running, which you can run queries against, and which also offers UI for if you have registered as a user, you can, for example, create your own collections of these terminology endpoints, and then query them. If you move to the next slide, then you will see the link to it, which I will also probably put in the notes later. So next slide, please. So this solves the problem of accessing different terminology services. But what about legacy applications that already have implemented the API of one particular service? So this is the next step, which is currently work in progress. We will provide an interface for the most common terminology services like OS, Ontoportus, Cosmos, so that queries are translated to the API gateway format and then translated to each of the endpoints, and then the responses are translated back to. So for example, if you already have an OS implementation, you already access an OS server, you can just use the API gateway in order to run OS queries against all kinds of terminology services, for example, Ontoportus or Cosmos. So these are my 7 minutes. Just the last slide's opportunities consist in, as I said, seamless consumption of semantic artifact catalogs based on different standards, integration of terminology service APIs in a declarative fashion. So we can always cater for more APIs. We just have to add a mapping in a declarative file, it's a YAML file. We can integrate legacy systems. And if you're interested, we can talk about it. We have resources for collaboration. We're always interested in integrating new services. And we also have this format of what we call incubator projects, where we can collaborate in a kind of formalized fashion if you're interested. So that was the API gateway. Thank you very much for your attention.
Thank you very much. Thank you very much, Ralph. That was a great overview of a different approach. So we actually welcome Clement back again. He's going to give us an overview of Ontoportal Federation as illustrated using Earth Portal and AgriPortal.
Hey, well, now I'm back. Indeed, we were thinking Christelle Pierkot, my colleague from the CNRS, who's driving now the Earth Portal project, will do the presentation of the Federation. So each of us would have done a presentation. But yeah, unfortunately, for some multiple reasons, this is me coming back. Christelle and I are closely working together now. She is pushing and now developing Earth Portal in the context of CNRS and the Data Terra initiatives, and we are developing at INRAE AgriPortal, a portal dedicated on agri-food. And those two portals are part of the federation that we have worked on in the context of fair impact. And so I'll demonstrate a little bit about that. So just to give you the context, Ontoportal is a generic technology to develop ontology repositories. That's our legacy term. Now we talk about semantic artifact catalog too. And it's being pushed by an alliance that is trying to synchronize and mutualize the research and development efforts in maintaining that technology to maximize the adoption of that technology and increase overall the semantic uptakes of what people can do with semantic artifact. In overall, the idea is to favorize and develop an harmonized way of accessing semantic artifact. So you see that the notion of federation has been intrinsically there for like more than 10, 15 years. I mean, the alliance is officially now 6 years, but the Ontoportal technology has been reused originally after BioPortal for more than 15 years now. So you see that we have this different installation of Ontoportal, which happens to be only a technology, not a portal in itself, in different domains from technological science, earth sciences, ecology, biodiversity, or our colleagues also from industry or material sciences. So two of those ontology repositories are AgriPortal that I mentioned, that offers different kind of services for ontologies, and vocabularies and semantic artifacts in general, publish, search, download them, browse, visualize, search, all of that in the UI and then in an API in the backend. And one of the key reasons also people come to AgroPortal or OntoPortal in general is that notion of having integrated a mapping repository also in addition of the ontology repository, but also a semantic annotation service, something that will, given some text, will return some ontology context, a recommender that helps communities to find out which ontologies are appropriate for their tools, and many more features such as fairness assessment, etc., etc. So this is the illustration of AgroPortal, and there is an illustration for Earth Portal, which is exactly the same approach developed by Christelle and our colleague also, Guillaume. The philosophy behind the AutoPortal Federation was that because we run the same technology, we are already compatible at the technologically speaking at the API level. So we were like, okay, let's take our APIs and make them talk to only one unique UI, you know, through the little bubble that you see in the schema here called our API client. Let's make that guy capable of, instead of talking one front end to the back end, to one back end, let's make it talk to multiple backends. That's all, folks. We got our federation. That's in theory. In practice, it took us more than a year to develop all of that. But the idea was that we could display the UI and consume the content in our UIs coming from different backends and without changing radically our UIs, because the backend will send back the same JSON to consume our data. And so basically, that's how it looks. The first commitment that the Alliance took, not the Alliance, but those 4 portals in the Federation took, was that if we want people to start playing together with ontologies, similar ontology repositories, then it will make sense to harmonize our UI. It was also kind of a requirement for our tools to, because of that UI federation. Then if the UI were completely different, then it would mean that every one of us would have to re-implement their own UI, implementing the federation. Here we did it for one UI, and by doing it for one user interface, then it was available for each of the others. And so we leverage the fact that now MOD also offer the semantic artifact catalog description of itself, and we use that feature, we implement that feature and then used it to make sure that each portal will be able to describe the other portal with which it federates. So if you go to, for example, to AgroPortal, you'll see the list of all of these portals that are members of the Alliance, portals that are public in the Alliance. And if you drag on some of them your mouse, you'll see the one with which we federate getting access to directly from the others API, based on the fact that now semantic artifact catalogs are being described in MOD API. So that's what I call the federated portal description. I should have actually moved to this slide already. The fact that the semantic artifact catalog object is now formalized in a standard MOD offering us that because it's based on DCAT, then the base service of AgroPortal offers now a description of this. And so you see, for example, in the UI, exactly what I was mentioning, that AgroPortal will be federated with, and you have a little pop-up like that that shows you that. One step that we also took was to say, well, if we want the content, if we want to harmonize our technology, then our front end, we want also the content to be described a little bit similarly. And so it's kind of hard to, overlapping portals in terms of domain. OntoPortal has taken very much a discipline-oriented approach, where each discipline they maintain and deploy their own thematic ontology repositories. So we were like, okay, let's use a unique category description, and for that we pick up the UNESCO thesaurus to describe at the higher level all of our semantic artifacts. So if you now go to one of the portals that are federated, each of them use UNESCO thesaurus at a higher level to describe their content, which really is the fact of selecting and identifying semantic artifacts. So the first service that we have actually federated is the browse page. And because of that categories that were unified, if you go on that browse page, for example, on AgroPortal or EcoPortal, Large Portal or BioDiff portal, you'll see the possibility of ticking the portals you want to get the data also from. And then the categories box will help you to filter based on that UNESCO unified category that I mentioned before. So here the screenshot shows you that a request on our staging box was calling different portals. You'll get the numbers. All of that happens in parallel, so you don't have too much time time lag, I will say, because it's queries are made in parallel, and then the UI integrate those results in one front end. And we have adapted a color code. And you've seen that the colors are adopted by each portal, and here you see that those colors are then reused to actually shows you in which portal the results will actually open. And we also detect the duplicates. If it happens that an ontology is present in two portals, which is a current situation in our ecosystem, then we'll find out the duplicates and also tells you in which portal it should open. And at that level, the federation agrees on the notion of canonical portal, where there is one portal as a reference for the other.
You're at 1 minute, Clement. Thank you.
Oh, okay. Well, I'm quickly showing another service that we have federated called the federated search. We have the same idea here. If someone fires a search on one portal and activate the others, then you will get results on the other portals with the same philosophy. If one result is relevant on another portal, you click and you move to the other portal. So federated search, federated browse. In the future, we plan to expand that technical federation, federating multiple levels of services that we have at hand inside the ontoportal technology, including the annotator, the recommender, but also synchronizing more the metadata so that users don't need to and curators don't need to copy paste that. But also eventually, the philosophy would be to also federate the whole management of ontologies, including loading, submission, things like that, in order to go towards something that we call federated science, support our community at a broader level because of that federation. So what are the opportunities, again, closing on this slide in the last 30 seconds? I will say, well, we have here shared technologies, diverse instance, and we've been building on top of that. So connected multiple ontology repositories, that was the same philosophy. So the interoperability is more here by design because we already share a common API. And then it actually demonstrates the kind of things we could do when we also have such an API. MOD API tells us now that's possible. But the fact that BioPortal, OntoPortal has a legacy API that actually very much more advanced shows us the way to go, also telling us if MOD in the API in the future implements all of that, then you'll be able to do these kind of things. Bridging communities, we can also now discuss distributed governance and of course, we are working together in a federation, then we want to acknowledge the fact that we need to rely on each other, things like that in terms of content, etc., etc. I mean, community empowerment, scalability, resilience also can be brought in by that federation, etc., etc. Actually, so much opportunities. I'm not even capable of listing them all. But thanks again for listening also on that part of the talk on the portal, on the OntoPortal Federation.
Thank you very much. Join me in thanking Clement. Excellent. Thank you so much. We have somebody in person now. This is Nick Carr from KurrawongAI, and we had a change in title.
Yeah, can I run this from here, or is Clement going to run it?
We could run it from there before. It should be working.
Okay, so with that one, this local one, let me just go to the start of my one, and then we're just zooming through.
There we go. Here's a recap.
Recap.
And we had a title change last night from Nick, which was actually really nice, and he'll explain why, I think, when he introduces himself. Experience-informed suggestions for further vocabulary service developments. Please welcome Nick. Thanks.
I did change the title. It was something a bit more authoritative before, but really nice.
Nick, you need to move to the mic.
Thank you. Yep, got it. Yes.
And you tell me if I think I'm still sharing the screen. Am I?
No.
So if it's the case, then.
No, I've got it now,
Okay.
Clement. That's okay.
Okay.
Look, I had a more authoritative, I know what's best for the world title, and I thought that was a bit rich, so I've just reduced it down to suggestions. So my background is I've been involved as a researcher in vocabs and then as a production engineer in the vocab space for a while. I've worked on some of the systems that you've heard talk about today, Alexandra's and so on. But at the moment, I'm actually running a company that does, among the majority of things we do are to do with semantic implementations, and vocabs are a large proportion of that. Vocabs are the simplest semantic system that we build, and it's usually the first, and at this stage, still the biggest set of things we do. Not the biggest in volume, but the number of organizations that do work. That's that. One of the other things I'll mention is I'm currently the co-chair of the W3C's Data Shapes Working Group, so that's Shackle. and graph validation, and that's important for some of the wild claims I'm going to make in a minute. Okay. So these are just some issues that, now, before I go into the specifics, I wasn't sure quite what the focus of this session was going to be, whether it was what I would call classification vocabs or semantic artifacts in general. So it's clearly more semantic artifacts in general. I think I've missed a little bit of the mark on that because these are a little bit more focused towards those simpler vocabularies. But nevertheless, this is still sort of true for the field as a whole. I still think we have a problem in that we need to communicate vocab patterns beyond basic SKOS patterns. You could say that this is also true for ontologies. Maybe people know how to do certain things with ontologies, but not all the things ontologies do. But in terms of vocabs, we often get people trying to do new things with vocabs that in fact some existing pattern already implements. So people will go and invent vocabulary versioning when there's a lot of patterns for that. They'll go and invent all kinds of things. And the three that I've listed there that I think are quite critical, so term versioning, I mentioned that. Agent representation, how you actually link your terms and your vocabs to representations of agents. This is simple from a vocab implementation point of view, but it's done in a wild number of ways. And people, sometimes you see wonderful ontologies that have got 1,000 classes and 400 properties, and yet their reference to a publisher is a literal text thing, and we can do better than that. The other thing that's really important, and this is true for ontologies as well, is statuses. The status of the definitions that we're looking at, whether they're vocabularies or ontologies, with respect to something, the register that the vocab's in, or this instance, or something like that. That notion of statuses is critical, life cycling of terms and so on. So I think these all enable reuse, they're all critical, and we have not solved the communication of the potential there, even though we've solved the ontological modelling of it. Here's just an example, very simple vocab register at an Australian government department, and they just indicate status, you know, stable, experimental, makes a huge difference. Okay. One of the things we're doing to try and improve that is just documentation, tooling, collections of patterns. We've got things like the linked the linked data patterns textbook that's been around for 15 plus years that tells you how to do linked data things. You know, how do I represent an agent in linked data? We actually don't have such a thing for vocabularies, or if we do, it's not as well known as it could be. So I'm trying to gather patterns that we have been implementing for quite some time and just document them better. And there's an example of whatever that one is, images or something. But, you know, how do I include images in vocabularies? That's the kind of pattern we want to indicate. Okay. Another pattern, I think, have I missed something? I think there's a slight ordering issue. Here we go. Okay, another issue. How do we indicate the complexity level of the asset we're dealing with? And this does transition from what I would call simple classification vocabularies to ontologies. Are we dealing with a SKOS vocabulary? Are we dealing with a SKOS vocabulary that's got extra stuff in it, simple stuff, you know, like versions? Is it a SKOS vocabulary with really custom stuff? I've got special relations in there. Maybe it's a simple class hierarchy, maybe it's a full ontology. That level of complexity needs to be indicated. It needs to be, you need to be able to work out what that is to know what you can do with that asset. And we can either allow people to spend forever and actually look at the asset and try and work it out themselves, or we could think of a more conventional way of doing that assessment. And I can think of such a way, because being in the data validation space, we actually can assess data to see what things it conforms to. And if we know that, then we know what complexity level it's at. It's like saying what AL profile does this thing conform to, but we don't really care about AL profiles. We care about, are these just simple SKOS objects, or are they SKOS, et cetera, you know, beyond that. So then I would go back here and just point out that we've got a class hierarchy on the right, we've got a little, what could be a SKOS hierarchy on the left. They kind of represent the same thing, but our impressions of what we can do with them and so on vary drastically. However, if we don't really understand what a class hierarchy is, we can still use this as a concept hierarchy with a profile view of the whole. Okay. The search for an API continues. We've just seen several approaches, and I've seen other approaches over the years. I will say about the mod API that it seems reasonable. It has momentum. It's easy enough to implement. Will it do all the things we want? It'll certainly do some of them. And I do suggest that we build on top of it. So that's coming in from the outside, saying that I was not involved in the API development. And in fact, if you saw one of Clement's slides very briefly, the systems I work on were crossed out because of lack of engagement. But nevertheless, Alexandra has been involved. We worked with her. So we'll do that. Now, I do want to say this, which is going to be a bit touchy, but what can Sparkle plus a known data model not do? So a Sparkle endpoint is a comprehensive semantic endpoint. It can get everything from the content there. The criticism of Sparkle that John and others have raised with me before is that it's hard to use. What's in there? How do I get hold of it? If we know what data is in the system by defining what profiles of data models are adhered to, we can know that. So I can know, for instance, that I can search for concepts if I know the things in there have concepts in them. So my posit is that, in fact, all of the APIs that we ever wanted just decompose down to a Sparkle endpoint plus some knowledge of the data models. And I do think that, that we could realize most of what we wanted in that way. We haven't declared those data models much. We keep using OWL ontologies and generic SKOS vocabularies, but we need to be a bit tighter about the data model, and then we'll know how to use them better. So my proposal is to extend on SKOS, profiles of SKOS that we've been running for many, many, many years, that tell you what metadata you should have. And I should say, and I will say now, this could include all the mod ontology elements. And in fact, I think it should. And I think this is what we'll do. We'll actually extend our profiles here to include all the mod ontology elements. If we know the vocabs are compliant with the mod ontology, we don't need a special API. We can just use a Sparkle endpoint with that data model knowledge in mind. We can make a query library. If you're not familiar with making Sparkle queries, someone else can do it for you, and you can just use them, but that saves us actually having to declare fixed endpoints. I think I've said everything in that slide. So let's see how far the mod API can take us. I will make a commitment, which is to the tool, within the tools we use, we will implement the mod API, building on top of the work that Alexandra's team have done. We've got a generic version of the tool that she uses, and we can say again, if the content we've got matches the mod API, mod ontology, we should be able to reveal the mod API from it. And we'll roll that out to the systems in production. So if you're using one of the press systems out there, you will get a mod API coming out of it, sort of whether you like it or not. But then again, the longer term test will be whether that API does something beyond what knowledge of the data model, mod ontology, and a Sparkle endpoint can give you. That's it.
Excellent. Thank you, Nick. And it should stimulate some great discussion. We've got John Graybeal here today in person. Yay. All the way from the San Diego Supercomputer Center and GoFair US. He'll be presenting a collaborative project documenting evaluation strategies for choosing terms and ontologies. Thank you, John.
Thank you, Megan. This is really technical, isn't it? You all can take a little breath and have about 5 minutes now for something that's much simpler. I'm doing a bit of a deep dive here on one particular part of what happens when you're trying to deal with federation of all of these different resources. This is a part of the OntoChoice project, which involves a team from many projects all over the world. And so I want you to imagine you're dealing with federation, and the particular part of federation is one of the ones that Clement has mentioned, which is doing recommendations. If you think about doing a recommendation engine for an ontology repository, and you're going to prioritize the ontologies that are recommended, or the terms that are recommended, you're going to use several metrics to do that. This has been done already. This is a real example so far. And you can then imagine that someone is using the same engine in their repository and making recommendations in their repository. This has also been done so far. Now you want to blend those two sets of recommendations from the two repositories. What's that going to be like? When you think it through, you realize that even if the recommendation engines and processes are identical, the blending process is going to be challenging. That's when the metrics are identical. But if the metrics are actually different in the two repositories, that's going to be really hard to deal with. And if some of the metrics aren't actually metrics, they're not even measures. They're just maybe classifications or other kinds of information. You're adding to the challenge of how can we possibly get a recommendation across all of these different repositories? How can we level the recommendations in a federated way? We can expand that to think about all the different kinds of recommendations or metrics that one might use for evaluating which terms or ontologies to use. And the first thing that you would probably want to do if you're going to be rigorous is actually consider all those possible metrics and consider which ones are going to be easy to federate, which ones are going to be easy to implement, which ones would you like this conglomeration of federated services to use. You also, having done that, will then try to build a couple of the best metrics, the most useful, the most federatable metrics. And that's especially useful if a lot of your code is federated, if the same metric can be used across many different, the same code can be used across many different systems. Oh, I have one of these. So the OntoChoice project got started because, not because of this federation problem, but because I personally got tired of people saying, how do I choose my terms or my ontologies? Just tell me how to do it. And I just couldn't, because it just depends was about as close as I could get. But I thought I would answer that by just making a list of all the different ways you could choose terms and ontologies. So we have a lot of work done since then toward that end. We have a 45-page white paper that you can visit and even edit if you just check in with the program to let us know your GitHub account. We can give you the access to edit the white paper. We have a team that's built up over the last 2 years especially. I've been working on it about 5 years, but the team has really moved it forward in the last 2 years. About 10 or 12 dedicated people, and you're all welcome to join. It would be delightful to have a few of you join. I have a few victims in the audience already. Thank you so much. We have a GitHub repository. We have a website. We have the original white paper is linked both in the top link there and in the bit.ly if you want to just type that in. And it's sort of cross-linked, so you just start in any of these places and you'll find one. I put these links in the notes, which you can get to as a bit.ly, RDA 25F, I forget, VA, whatever our acronym is. But you'll see it coming up in a few minutes as well. And please sign up, by the way, if you're interested in all of this. Please put your name on that so we can contact you. The position paper that we're creating to say what is this project and why is it needed and why should you contribute and we need more people to help do this is pending. All of us are volunteers, so you can imagine that's a bit of a constraint if we have 10 or 12, quote, dedicated people. And we're working on exemplary tooling that can help frame examples of some of these measures. So the opportunities here, I think, relate to what the Vocabulary Service Federation's biggest payoff is going to be. If you're able to more quickly find more and better vocabularies and terms, that's going to be really powerful. To choose the best vocabularies and terms, you're going to need a lot of federated evaluation strategies. And those have to be well understood strategies. They can't just be random collections of things. So OntoChoice is offering this one-stop shop that lets you identify and understand and test. The in progress refers to the test, and improve strategies and services to evaluate vocabularies and terms. So please have a look. Join us if you'd like. ontochoice.github.io. See you there.
Excellent. Thanks, John. That's something for us all to have a look at. That'd be really interesting. So next up, we have another in-person, Rob Atkinson. He's from the Open Geospatial Consortium, and he's presenting requirements for a general solution to implementing FAIR principles for vocabularies in a scalable global data ecosystem. Welcome, Rob.
Hi, well, this will be a little bit of a change of pace. It may be technical, but it's a different type of technical. We're going to go deep into architecture and think about scalability. So basically, there's a lot of stuff happening. And I represent OGC, a standards organization, but I also work with W3C and ISO, and we have lots and lots of liaisons with other people. And big infrastructure systems like Copernicus, the European Space Agency, and NASA and that sort of stuff. So we look at all these activities like we've been talking about and say, that's great, you need to have those things happening at that level, but we also need to look at a slightly bigger level. And I've got a few thoughts I want to walk through. So the big thing is that a lot of those infrastructures are not going to adapt semantics. I mean, much as I love it, I develop ontologies for fun and pleasure and work, but people who have a GIS system has a bunch of code lists. They're going to maybe want to expose that. Someone needs to know it. I've got a couple of examples here. One of the big ones is the building information management systems. There are thousands of people out there with their own flavors of engineering, with their own control vocabularies they use and lots of overlap, and they're not going to turn around and say, okay, right, we're going to rebuild our systems on anybody else's systems. Getting them even to expose this stuff with APIs, okay, it's a challenge. So that's just a bit of a scope of the problem, which is why I want to talk about the requirements. Just looking at some of the key patterns, getting away from APIs, which are just a means to an end, let's think about the content. So there's a whole bunch of different strategies that people use. Often what they do is they bring a whole bunch of vocabularies into a single location, okay? Sometimes you will then say, okay, I'm going to go to AgriPortal, which has aggregated a whole bunch of things, and I'm going to use this subset, okay? Or I may use some part of that in my system. Classic example of this is if we take things like GBIF, the Global Biodiversity Information Facility, its taxonomy database. It's massive. It would change before you finish downloading it, okay? I'm only interested in threatened species in New South Wales. In fact, I'm particularly interested in green and gold bell frogs, okay? Now, I've got an interest in a subset of that thing. So this, for me, is a big federation problem. It's not how do we deal with just querying these things or whatever it is. It's how do I declare that I'm interested in that subset or I'm contributing this subset to a bigger picture. So there's a bunch of patterns like that which, as Nick's saying, I don't think we've really nailed a solution for this stuff, but you can see it's not one pattern, there's a bunch of them, and I think this is where we need to be thinking. We can have a simple solution, but it must not be a barrier to all the other patterns which have to coexist. So that's the first thing I really want to discuss. The second thing is that we're probably not going to get one universal API. Okay, we've got a whole bunch of things that are already out there, but we know, like with electricity plugs, we can deal with adapters around a small number of them if we have coalescing of things. So things like the Interoperable Alliance is fantastic because it gives us one of those things. Not because it solves everybody's problem. We're not going to rebuild somebody else's infrastructure. We're not going to get the US to go to 240 volts tomorrow, but we can deal with a small number of things. So it is good to coalesce around simple solutions, but we also need to think about how these things fit together. So I think the key opportunity here is if we can get federation of subsets right, how we describe that, then all the rest of those use cases will become relatively trivial because it's just a complete subset. So, the temptation is to say, oh, we'll just do something simple. But if that simple thing doesn't actually cover the real use cases of dealing with the fact that fundamentally we are sharing, these registers are dynamic, they're growing in many cases. I mean, the register of motor vehicle identification numbers, the registers of species names, the register of the machinery of government. These things change all the time, okay? We've got to be able to understand, okay, how do I reference a subset of one of these things that is accessible via a service? So we need metadata patterns for describing that. We don't have them yet. But that's an area where if we can nail that one, everything else will become simple. And part of this problem is, now I'm trying to think about how we fit these things into OGC standards. We have all these OGC standards. If I were to start helping them specify what the content is, now we need to identify some common patterns. Okay, so we are thinking of looking at launching a terminology standards working group where we'll look at profiles of our standards, which is kind of consistent with what we've heard, where we look at how we reference terminology. Okay, so the main thing here is that the solution kind of has to be technology neutral. There's a lot of stuff out there, okay? All those federation models coexist. It has to be fair, obviously. We need software libraries to be able to support these things easily. We use a thing called Open API. Like Mod API is an Open API thing. That's great, but it tends to be, monolithic Open APIs get very complicated, and what we've just heard is nobody's implementing the whole thing. So I would look at Mod API, modular Mod API, and actually look at which profiles people actually implement. So I would start with Mod API, and we'll probably implement it, but we will decompose it into the various services it actually supports, and publish those services individually as APIs and identify the profiles, which is not inconsistent with what we've heard in practicality. So once you've done that, we've got these layers that you can combine. We can combine these with the OGC API, Open APIs, which is exactly what we've sort of seen Alexandra and British Oceanographic Data Centre do. No one's doing all of it at once. We don't have to do all of it at once. So the first step is to decompose Mod API into the services we need and learn how to use them. So, and that's, I guess, if we start with that, I think we'll probably be okay.
Beautiful, very thought-provoking. Great, I think we've set up well for a discussion. We have got about 20 minutes, say. So if the people presenters in person would like to come sit up the front, and we'll work on getting the online presenters up. Online people, you're very quiet. Brandon is telling me there are no questions. Nothing in the Google Doc. It's all solved. Done. Go home now. So if you do have questions, pop them in the chat. We do have one question in the room.
I will ask you a question and after give you back the microphone. That's a question that I asked often because I think that's one main issue when you have a choice to do for a technology, but also for content, for semantic significance and concepts that are behind, how to evaluate the quality of what you chose.
I'm happy to take this because one of my little crusades is to say FAIR is about evaluation. The goal of FAIR is reuse. Everything else is a means to the end. Okay? And you don't get reuse until you've got a business decision that it's a good idea. So somewhere, when you find it, then you start accessing it and having a look at the data, then you understand how interoperable, how much effort is it going to take to assimilate this. Eventually you make a business decision to reuse this thing. So again, John talked about evaluation, which was fantastic. I think that FAIR without the evaluation component is problematic, and you end up saying, oh, we'll just do F, we'll just do discovery metadata because we understand that. And discovery metadata has been throwing the end user under the bus for the last 30 years in the spatial data infrastructure world. So I totally agree with you that evaluation is the critical thing, and you need a lot more metadata to evaluate than to find or to access the data. And that's kind of why I talk about scalability. We need to make sure that we are not doing fixed metadata schemas. So if I take, for example, again, I don't wish to criticize because every metadata schema is exactly the same, but we saw the mod API metadata schema and we say, okay, all these properties exist, but everybody else's profile is going to use similar subsets of those. Okay, there's going to be, okay, maybe there's a, the vocpub profile is going to use a different subset of the same set of properties. You need these. So maybe we can layer these things out into reusable pieces that deliver a particular business proposition. And then we can think about, well, what are the evaluation criteria that's needed for different circumstances? And it's going to be very variable. If you're looking at a phenomena in the real world, you care about your sampling regime. How granular is your sampling compared to the variability of the phenomena is critical to know what signals are available in that data. So if you look at Earth observation, absolutely, if I'm going to run a pass once every 3 years, I'm not necessarily going to see seasonal variations, okay? if I look at something which is changing every hour, you know, a daily pass isn't going to be very useful. So we have some examples of things like, I don't know if people come across STAC, Spatial Temporal Asset Catalog. It has an extensions mechanism where people say, okay, right, here's an extension of my metadata. It's a crude starting point, but I reckon highly modular metadata design that allows us to build on these additive metadata profiles where you can add more detail according to your application and make those fair, okay? And we have different metadata standards, so we have the mappings between them, which comes back to some of the Clement was talking about. Those fair mappings are important. We're not going to all agree on the same metadata standard, but if we can break it down into smaller pieces before we try to map them, it's going to be a lot less complicated than if we try to map these monolithic things that everybody's used differently to put enough metadata to actually evaluate in. So that's a long answer, but there's probably only one way of doing it, which is breaking it down into small pieces.
Thank you. Excellent answer. And I thought we shall give the folks online an opportunity to respond to that. If there's somebody in particular that might like to respond, you could unmute. Clement, you have your hand up. Excellent.
Hey, thanks, Romain. I think it's you know from the question of quality has always been coming back to the picture. What we are trying to do as providers of proxy to access the knowledge of others that have been formalized by others is enough element for them to evaluate the quality. And so, yes, indeed, as Rob said, the FAIR principle has been also very important for that. I mean, as you know. At the end, sometimes I hear the debate of quality very often, but I like to sometimes bring in the parallel with cars, you know. We all know what's a good car and we all know what's a crappy car, but still, it doesn't prevent us to drive some crappy cars, and people are still driving crappy cars because they are good for them to go somewhere, and there are multiples of good cars. And so I think, and you know, from certain branding to another one, everyone has a different good definition of what's a good car. So I'm trying to say here that the notion of quality happens to come back like every time. Oh, you want to be sure you do quality, you do quality. Otherwise, if you don't do quality, you're bad. But you know, that notion has been so fuzzy and so specific to use cases that it's always good to know, yeah, we all know what's good, what's bad. But when you dig into the detail, then we don't know each other anymore. And we all know also that people sometimes use things that you will not use yourself because you consider it cheat. And so I'll bring enough information. What MOD is bringing you is a normalized way of actually describing things, in our case, semantic artifacts, so that people can make their own intelligent choice, so that people can use, for example, and select, as John was presenting, the right terms for the job, or as we were presenting in that notion of federation, the right ontology for the job. That's really up to the people but they should not expect us to say, well, look, that's the best one in the world. Otherwise, there will be no such a response for everyone.
Excellent. Thanks. Alexandra.
Yeah, I may give a little bit of a different perspective in this question, which is the community. So at least in our case, our community knows which are the vocabularies that they use. So if they are looking for a term, picking a term from a vocabulary that is not used in our community is going to create problems. And because vocabularies are really there to create interoperability, the unspoken contracts that we have within our communities of which vocabularies are good to use is very important. Maybe having a way to actually say that, you know, this is the list of vocabularies that this community uses. Or, for example, we all know that DCAT is a standard for describing datasets. It's not that somebody came and said, go and use it. It's an unspoken rule between all of us in this community that we know this one is to use for describing datasets. I don't have an idea of how to actually express that. Maybe it's how many other people are using the same thing. And I don't know how you actually discover that.
Yes, thank you, Alexandra. And Clement, I agree, as a long-time Peugeot driver who's had to give them up very sad. No one can fix it for me. The parts are too expensive. I don't think there's any questions online. Yeah, yep. Then I thought what we might do is jump to that drafted statement that we popped up, see if there's any feedback on that. And another question, awesome.
Yeah, there's one more aspect which I wanted to highlight. We're currently running a thing called the Open Science Persistent Demonstrator with European Space Agency and NASA. And we are focusing on the IPT, the Integrity Provenance Trust. In particular, we're looking at how we introduce a standardized provenance model, and the W3C publishes a provenance ontology. But there's also a thing called the Common Workflow Language, which is a sort of a schema for describing the sort of steps at lower level detail. So we're currently looking at adding provenance in a systematic way to our metadata standards and mapping various stack extensions that have been used in Earth observation up into DCAT, and in this very modular fashion. So there is a bunch of stuff happening there, which hopefully will be a demonstrator of how to do this in a modular way. But provenance is a key factor of evaluation. If you can see what's being used and who's using it and how they're using it, then you're going to have now a lot more insight into how the community sees that data. So that's the dream, is some scalable provenance starting to appear in the metadata we use.
Awesome. And yes, we have a question here. And remind me, we have to come back and you have to tell us about your charter, the OGC. Rightio, and chat about mechanisms of ways we can go forward and collaborate. Speaking of that, we have Gwen online too, co-chair of the Special Interest Services Group, Vocabulary Services Group, right? And we have a question here.
Hello, Pedro Hernandez, Master University in Netherlands. I'm gonna ask, I guess, the AI question, because somebody got to ask the AI question. So what do you guys think, or some of you have any vision of what the landscape of vocabulary services will be? With the advent of agentic AI, of course. So then you're gonna have users in the future that are going to start to, find terminologies, etc. And how do we make sure, as Clement mentioned, if with all these technologies we are basically proxy for knowledge filtering somehow? So how do we make sure that agentic AI will do the right choices in the future?
Go ahead and give them the mics. I was just going to start by saying, I think the current status is oddly that AI can't understand what an ontology is at all. And so my prediction, based on the progress we've made in getting the correct answers out of AI, is that there will be an extended period where what we get is kind of crappy, unless you just like how authoritative it sounds. That's my current resting place. I'll turn it over to people who really know. Yeah.
So my day job is to run a company, and the company actually does AI. It's in the company name even. But the thing that we like to do to try and differentiate ourselves from all the other AI companies out there is actually to have a knowledge of data semantics. And so I'll just give you an example rather than trying to sort of talk about general patterns. So here's an example. A mining company came to us and said, can you make sense of all this data? We've got 400,000 documents. We've got all these data sets. We've got all this stuff everywhere. Now there's a pattern and a logic to what they've got. They in project folders, they've got typical kinds of files, the normal stuff you would see in a relatively well-organized company. What they didn't have is any sense of a domain data model. They had a data management data model. These are the organizations, these are the projects, this is the timing, and so on, but they didn't have a geology model, for instance, in there. So we just looked at the geology ontologies and the geology vocabularies that we already knew about from elsewhere, and we processed their content using AI against that background set of semantic assets. Now, the Geological Survey of Queensland, the state you're in right now, publishes a couple of hundred vocabularies that Vance over there made many years ago. And they are simple vocabularies. These are classifications of rock types and all this sort of stuff. They're SKOS vocabularies. They've got no huge amounts of semantic content. They're just classification vocabularies. But altogether, those 200 vocabularies cover off an awful lot of axes of classifications of things within the geology domain, and they present a huge amount of terminology. So to process 400,000 documents against those vocabularies, we do a much better job of understanding what's there than just relying on large language models that know mostly about English. Now, large language models are trained against geology textbooks. We know that. They know what crystalline rock structures and all this kind of stuff actually means. But to have specific terminology that must be used in the case of compliance, or that represents the best case synthesis of experience, to process semi-structured data against that is incredibly powerful. So our results now, when you search one of the, you search the AI thing in the embedded interface that we've got, when you do a search, it'll interpret what you've asked in light of any synonymic matches and so on it can find in those vocabularies. It'll search the content against that. It'll return the results to you in plain language and indicating what elements of vocabularies and models were used. So I actually think we get an enormous amount of skill from just having a bunch of vocabs. The more complicated ontologies provide us with more power. Yes, John's correct. We're not up to fully understanding those things yet. However, if you see a document that talks about something in an ontology, and the ontology links to something else, some data set, you get from the ontology an association which the document didn't have. And so we don't have to fully understand the ontologies with AI. What we do have to do is to use them with AI, and that's a different thing.
Okay, this is just following up with that. And there's a lot of other ways of looking at this too, and it comes down to the problem of breaking things into small things. If you give an AI a large, complex problem that hasn't been solved, it will fail. It will hallucinate an answer, but there is not enough solution to the problem. But if you can break a problem down to lots and lots of small problems, now, for example, like identify the vocabularies that are in use in a particular data set, and then get it to do lots of little jobs, you can often get things which at least you could look at and evaluate and say, right, so I actually use it all the time. I use it to say, okay, right, I've got a whole bunch of data. No, I can't find a schema. Generate a JSON schema for that set of JSON. And I look at it and say, okay, right, now, if I give it a small enough task, I can very quickly look at it and say, okay, right, I'm now done. It's done 80% of the job for me. I can fix it. But if I told it to solve a big problem, no one can ever deal with the mess it makes. So I think now the bottom line is that when you start connecting the dots with the linked data, you can put a lot more context into a model. I don't know if anybody knows the model context protocol, but it's one of the things we're currently looking at linking into the OGC API processes. So and the workflow, the common workflow language. So how do I chain lots of agents together and reference them and actually validate them against requirements? Profile semantic artifacts are really good for doing that. So meet something that meets this profile. But if you give it a big problem, like, give me, the whole, if you like, the whole mod API metadata model and say, match that, it won't do it. But if I ask it to solve a little part of it, it's probably going to do a reasonable job. So it's very much evolving, but divide and conquer is the only way it'll work, I reckon.
Awesome, thank you. We have 7 minutes, and I'm just conscious that, well, Clement, I can see you've got your hand up. I'll flick it over to you in a couple of minutes and you can wrap up. Oh, you've got multiple hands up, and yeah. We'll hand over to you in a couple of minutes. You can have the floor to wrap up. So if you want to chat about your point then, because we've got Ralph online, and it looks like Gwen's joined us. So we actually have we'll have to be quick, guys, but Ralph, there's a question for you from the online chat. It's is there a particular reason why Bioportal wasn't included in the list of ontologies supported through the API gateway? And also, actually, Ralph, do you have any general reflections on this session that you'd like to add while you've got the floor?
So that's actually a good question. So Bioportal is actually supported Let me just check. So the thing is that BioPortal is actually part of the OntoPortal initiative. So transitioning to basically providing this common interface that all of the OntoPortal members have, and thereby it is basically support or will be in the future as soon as the transition is finalized. So, Clement, please correct me if I'm wrong. So the BioPortal, at least the BioPortal people are on board of the.
From what I've followed in the implementation of the gateway last year and before your time, Ralph, by the way, and as a collaborator, is also that the gateway actually consumed first the APIs that were providing by those 4 or 5 ontology repositories based on OntoPortal that were working together and offering a bunch of additional services. And so that's why BioPortal, that is not included in that set, was not directly involved. But that's I think that's just a matter of introducing now new component in that UI that you have shown, Ralph. So integrating any other OntoPortal based software is no big deal in the API gateway, from what I understood from the original development.
Right. So trying to think about how to wrap up that statement of intent to collaborate, guys, that we drafted. It's in the notes, so put your email addresses and your contacts in the chat, and if you're a vocabulary service provider or related service, pop your thoughts down on how ways we can converge here rather than diverge. And Gwen, do you have a comment you'd like to make quickly, and then we'll pass on to Clement to wrap up.
Hello. Sorry, it's quite early here, so I didn't want to put my camera on, but I think thanks a lot for a great session. I think from all the talk we've had, we can see that there's a lot of convergence, and we can, work together and make sure that all those technology bridge each other. I like what Rob said, that we shouldn't focus on the technologies that's going to stop other technologies from developing. So we need to keep flexibility. But also, I think we need to think and prioritize the end user. So, trying to, maybe with the support of AI and bring AI and semantics together to enable end users who don't really want to know about the technological background to encourage them to use semantic artifact right from the start. So to enable scientists to use semantic artifact right from the start at the time they create data. Okay. I think that's really important.
Yeah, great. And Clement, and not so subtle. Wrap it up, guys. I need my coffee. Little symbols happening there. Great. Take it away. Wrap it up, and we'll sign off.
What the coffee sign was for Gwen, not for you guys in the room. I know this is the afternoon.
Yeah, we could all see. We could all see it.
No, it's early in the morning here, but we are very pleased to be here with you. Just a note for Pedro that I put in the chat, continuing or filling the metaphor related to cars. You're right to ask the question of AI. We all know it's going to change the world, it's going to change our job, and as some of our panelists said, they actually answer very well the point of all using AI, for example, with ontology engineering and things like that. I just want to say, it's not because some cars are going to drive by themselves that it changed our business that we discussed today of choosing the right car, making the right more interoperable, and having them fluid and drive with the same all around the world. So, it's not because they're going to drive by themselves that those problems are being put on the side. And even if you want the driveless cars to move even forward and goes even better, then you want to be sure you have interoperable standards such as gas and oil to put them in, that make them interoperable all over the world. So indeed, we can ask that question and the elephant in the room of how you're going to use AI, but it doesn't change the fact that we still need to build interoperable standards to make our stuff interoperable And when the APIs and catalogs are described with MOD API, you'll see that the MCPs that were also mentioned by Rob will be more powerful and will be and LLMs and tools will be able to leverage the content of our semantic artifact way more because of that standard API implementation. So I hope it comes back to you, Pedro. Well, overall, concluding, I mean, the statements that we put on and we were thinking about discussing is really the discussion today. Wrapping it up was like really about how can we maximize the value of working together. So some of us are providers, and we came all together today. Some of us know each other's, others less. In front of you today, we came in order to show what we have achieved and also to help us motivate and found out new collaboration and ways of working, continue to working on those things. I think a lot of very positive things are being demonstrated. I'm happy to see that people still believe in that vision of an API that is not perfect. And of course, as you said, Rob, also multiple choice, at least as if there is not too much of them, the API gateway is demonstrating that this is possible to handle the complexity if there is not 10 or 12 of them, but 5 or 6 format are good, and we should be able to rely on them. And so I wish to find the appropriate context for us to develop that. Just want to say Fair Impact has kicked off a little bit some of these activities, but I really call also for this community to try to find the right, grants and funding opportunities to actually work on that, because this is not easy to develop software and semantic artifact catalogs in the context of project where people want to discover what's the way to cure cancer or save the bees and agriculture all over the world. So what I'm trying to say here is that we need to come back to our use case and also feed our federation by use cases and users. But yeah, if we have opportunities, I think there will be good to take them. I mean, OGC, W3C also have groups and structure on which we can rely. I really see a lot from also working with this experiment community on writing shapes or writing standards for them. I wish MOD, for example, could join such a mature process for standardization. So, well, wrapping up in one sentence, I would say that was a kickoff for talking about federated vocabularies, and I'm really happy that we were able to present our stuff here. We'll take the feedback of everyone online, everyone offline after this talk for sure. So feel free to react to some of us in the room or some of us online, and we'll be happy to continue on these topics.
Can someone who's online please save the chat and get it back to us or get it into the notes, because we don't get to see it. Thanks.
Thank you. I think we can wrap it up there. Any further comments? Use that discussion document. So thank you, everybody. Going off and. Opportunities to collaborate. Who wants to collaborate? Yes. Who's got an active who has an active opportunity? Yeah. Yep. Yeah. If you've got questions, come up and see us up here and we'll make sure you've got that document and we've got your email. Yes. I think my favourite part of the day, Alexandra, was what you're saying was link data, link people. I just thought that was awesome. I think that sums it up nicely. So thank you, everybody. Big round of applause and we'll wrap it up there. Thank you.
Thank you, everyone. Have a good day.
Thank you, Alexandra.
You too.
Thank
Enjoy
you,
the rest.
Ralph, Gwen, Clement.
Thank you. Bye. Bye.
Have the rest of
Thank
your
you very
day.
much.